Hello and welcome back. So far, we have understood some fundamentals like Python, Pandas, NumPy, descriptive statistics, and some part of inferential statistics. Let us try to understand the impact of statistics on machine learning. Before we understand the impact of statistics on machine learning, we have to understand at least one machine learning algorithm. So let us try to understand the simple linear regression and multiple linear regression at a high level. Before we start the algorithms and how they work and things like that, let us try to understand what are input variables and what are output variables in a problem. So the problem statement here is predicting salary using employees' experience and the lines of code they have written. So we need to predict salary based on the amount of experience and number of lines of code they have written. This is a regression problem. So there are two kinds of machine learning problems. One is regression and another is classification, especially in supervised learning. So this is a regression problem. Why we are saying this as a regression problem? Because the value we need to predict is a real number. The salary is a real number. When we are trying to predict a real number using some input variables, we call that as a regression problem. If we have to find whether the input variables belong to a category or not, that is called as a classification problem. We'll see these two things in depth in our course in coming classes. But this is a regression problem as we are trying to predict salary and salary is a real number. So here in the sample data set, we have got two input variables, experience and lines of code, and output variable salary. In supervised learning, it always tries to take some input variables and tries to understand the relationship with that input variable to the output variable. The input variable and output variable can be called as different things, like input variable can be called as independent variable, explanatory variable, and output variable can be called as dependent variable, target variable, and response variable also. In supervised learning, it tries to take the input variable values and output variable values and then tries to understand the relationship between them in an equation. So if I tell you the 1000 SFT house is 1 million, 2000 SFT house is 2 million, and 3000 SFT is 3 million. If I ask you what is the price of 4000 SFT house, you will immediately say 4 million because you understood the pattern, the relationship between the SFT area and the price. It is 1000 into the SFT area is the price. So the equation there is 1000 into SFT area. Price is equal to 1000 into SFT area is the equation. So that is machine learning. That is actually the machine learning. The quantity with which you actually are trying to multiply the input variable to generate the output variable or predict the output variable is the machine learning. So machine learning, supervised learning algorithms need already existing historical outcomes and the input variables which affected the outcome. Okay, so here we have taken experience, lines of code and salary for that purpose, and we will pass this data or feed this data into machine learning algorithm. The algorithm will derive an equation and we will call that equation as a model. We will use that model and make predictions for the future data. So let us try to understand what is machine learning algorithm with a simple flowchart. So here this flowchart is actually explaining you how exactly machine learning algorithm works at a high level. When you pass training data in this example is experience and lines of code are the input variables, the x's, right? And the salary is the output variable, the y. When you feed the data into algorithm, here we are taking linear regression as example because the algorithms will have hypothesis function. The linear regression's hypothesis function is the linear equation. What is linear equation? Y is equal to mx plus c. So the linear equation here is theta 0 plus theta 1 x. This is theta 0 is c and theta 1 is m and x mx plus c. So this hypothesis function for linear regression is a linear equation. So when you feed the data, the algorithm actually learns the hypothesis function. Here the linear equation it learns. When you pass a new record, it actually substitutes that x into this equation and makes the prediction. Generally, we call prediction as y cap. This is the y cap, right? Y cap. So let us try to take our example, the data set, whatever we have taken, and then try to feed it into a real machine learning, the linear regression algorithm, and see how exactly it is learning and what it learned. So here we are feeding the experience and salary. We are saying simple linear regression, and we are using only one input variable x and one output variable y. So when we feed this data into the linear regression algorithm, it actually understood the pattern. When I say understood the pattern, what it does is what is the number it should multiply experience and how much constant it should add to generate the salary values existing in the training data set. When you pass the trained data set, the algorithm tries to multiply the input variable and add some constant and tries to generate the output variables or the salary. So here it multiplied experience with 5171 and added around 7882 number that actually generated the salaries in training set properly. Okay, so how did it find? Let us try to understand that. So it is actually a little bit of linear algebra, right? So if you look at this data, I am calling this as x and this as y, right? So we have got 15 years of experience and 85,000 salary. So when you pass this data to linear regression algorithm, what I am saying is it is trying to learn this hypothesis function. In other words, or in generalized terminology, the h of x is equal to theta 0 plus theta 1 x. What is x here? The experience is the x, right? H of experience is equal to theta 0 plus theta 1 into experience, right? This is the function. So here in this data set, we have got experiences, so we can form the equations, right? Experiences or h of x is nothing but y cap, right? We are trying to predict y cap, but we can actually form equations like this: theta 0 plus theta 1 into 15 is equal to 85,000, right? When you multiply the 15 with some number and add some constant, you should be able to generate this 85,000, because we are trying to find these generalized numbers, right? These generalized numbers we need to find. That's our goal. To find out that those generalized numbers, we actually can form the equation like this. 15 years of experienced guy is getting 85,000 salary. That means there must be some pattern, right? So for the second record, theta 0 plus theta 1 into 3 is equal to 25,000. Like that you can form the equations for all the records. For understanding purposes, how linear regression is learning, let us try to understand or try to derive theta 0 and theta 1. So when you subtract one equation from another, what happens? These two get cancelled and you will get theta 1 into 12 is equal to 60,000, right? So then theta 1 is equal to how much? 60,000 divided by 12, right? So you can actually do that math, and when you substitute the theta 1 into one of the equations, right? Theta 0 plus 60,000 divided by 12 into theta 1 is equal to 60,000 divided by 12 into 3 is equal to 25,000, right? And when you cancel this to 4, and then you can actually 15,000, right? And theta 0 is equal to 25,000 minus 50,000, 15,000 is equal to 10,000. So we actually derived theta 0 and theta 1 by solving two equations. These numbers are not equal to these numbers because we have taken only two rows. But if you take all the rows at once and try to do this kind of linear algebraic calculation, you will find theta 0 and theta 1 more generalized numbers. Those generalized numbers are these two, right? So the linear regression algorithm is going to take all 32 records and form equations and solve all of them at once, and find the theta 0 and theta 1, which is nothing but the pattern, right? The pattern is what? You have to multiply the experience with some number and add some constant to generate the existing salaries in the existing data set. If that is happening true, or the equation is predicting salaries properly, right? You can use that equation to predict for the future records also. So here what I did is I passed 12.2 years experience and then predicted the salary as 70,000, 976, right? So this is how the machine learning algorithm or linear regression algorithm is learning or understanding the pattern. So if you try to look at this graphically, right? When I said the linear regression algorithm, it is actually forming a linear equation, right? This is a linear equation. How exactly it looks graphically? This is how it looks. So this magenta, this sea green line is the equation we found just now, right? The intercept or the constant of we added, right? Theta 0 is actually the intercept, where exactly it is cutting the x-axis, and the theta 1 is the slope of the equation. So all the magenta dots are the predictions. When you make prediction using the equation found by the algorithm, the dots are going to be on the line only, right? And then the actual values are the green dots. So the gap between the green dot and the magenta dot are called the error. We'll try to understand this thing more with code in a minute. So let us jump back to the code and try to understand. So here the data set is like this, right? I have imported the pandas, numpy, matplotlib and seaborn. You already know that, and I have imported the stats models, the formula.api. This is actually one module which actually has got machine learning algorithms implemented. We understood the concept. We just need to use the API and execute the code, right? So the stats models has got ordinary least squares, a linear regression algorithm implementation. So let us try to use that and see how exactly we can actually build a model and make predictions. So in a machine learning model building process or data science model building process, first we need to load the data, then we need to do some exploratory data analysis to understand whether there are any problems in the data or not. Generally the problems are going to be nulls, outliers, and errors, quality issues in the data, right? If there are any such things, we need to fix them before we feed the data into machine learning algorithm. The other thing is we may have to convert the categorical data into numbers. So in this particular salary data, right, employee salary data, we have got 7 columns, out of which designation is one column, which is a categorical column. We need to convert that into numbers. To convert categorical column into numbers, there are approaches like one hot encoding and label encoding. We'll cover those things in future classes. But for simplicity, what I am doing is I am taking the experience, lines of code and salary only, right, and creating a small data set. This data set has got this data, the experience, lines of code and salary. So for simple linear regression, we'll use experience as input variable and salary as output variable, and lines of code will not use it for now. Okay, lines of code we'll use it in multiple linear regression. So here I am actually calling describe method on data frame to see how exactly the data distribution is. Numerically, I'm trying to understand. So here, if you see the minimum, maximum, interquartile range and all that stuff, right? The distribution or the range of data is different. Range of different columns is different. For some algorithms, all columns should be in similar scale. So to have a look at it or to understand whether the data is in similar scale or not, describe method can be used. There are other important uses of describe method also. We'll see them in coming classes, but at a high level we are trying to see it right now. And then we may have to look at distribution of data to understand data distribution and fix some problems. One example is that if data is normally distributed like this, you can take mean and replace the nulls, right? So I am trying to look at distribution of salary column and experience column and lines of code column. Here in this particular example, I am not using the distributions outcome, but in future we will definitely use it. Okay, so the next thing we are going to look at is, or we are going to see is, experience and salary only we are going to look at, because we are trying to do a simple linear regression. When I say simple linear regression, only one input variable, only one output variable. When I say multiple linear regression, many input variables and one output variable. So we'll talk about that multiple linear regression in next video, right? For now, we'll focus on the simple linear regression. So here, to build a model using ordinary least squares, we actually need to call the OLS method, where you need to pass formula is equal to, the formula is one parameter which actually takes the input variable and output variable separated with a tilde symbol. If you see this here, salary is the output variable, that should be the first one, and then a tilde symbol followed by the input variable, and then from which data frame it need to pull the data. Data is equal to salary data, right? Salary data is the data frame from which it need to pull, and it's going to pull out the salary of the salary data of salary and salary data of experience, and then it will fit. When I say fit, what is it doing? It is actually forming the 32 equations, because 32 records are there, right? Theta 0 plus theta 1 into 15 is equal to 85,000. Theta 0 plus theta 1 into 3 is equal to 25,000. Like that, it's going to form all the 32 equations and then solve all of them at once and find out the coefficients. When I say fit, that whole thing is going to happen, and that outcome is going to be saved in this linear model, this variable, right? The linear model variable is going to save the outcome. Outcome is a simple equation, right? So when we actually ran this code, right? Let us run this code, execute this code. It understood. So now we can actually make predictions. To make predictions, I have taken some test data where I have got experiences but not salaries. So if we look at this data frame, experiences are there, but the salaries are not there. I'll pass this data frames experience column to make predictions. So when we are building the model, we actually passed a data frame with experience and salary column, right? So we may have to pass the similar kind of data frame here. Especially we need to pass. We can pass a series object or a data frame, but the column heading should be experience. That's the point here, right? So to simulate that, I actually created one more data frame and passing it to the predict method. The fit method will actually find out the equation. The predict method will substitute these x values into the equation and make predictions. So when I execute this, it predicted 70,000 for the 12-year experienced guy, and the 78,000 for the 13 years experienced guy. How did it got these outcomes? It actually understood the pattern in historical data, the trained data. In the training data, it has got the output variable and the input variable. It actually tried to understand the pattern between those two, or relationship between those two, with a linear equation. So the same linear equation it is using here. So that's the kind of how you build a linear regression algorithm, and how the linear regression algorithm is understanding the patterns and trying to predict. And in a nutshell, we can say a model-based learning algorithm, how it is actually learning or understanding the patterns inside the data. So let us try to understand more about the connectivity between statistics and machine learning in the next video. Thank you.